Hello dear students, all of you welcome to Vidyayana classes. Today we will discuss some expected board questions on continuity. First question, examine the continuity of the function fx defined by fx is equal to x into sin 1 by x if x not equal to 0 and its value is 0 at x equal to 0. Answer. Giving f0 is equal to 0. That means value of the function at x equal to 0 is 0. The function will be continuous at x equal to 0 if its limiting value is equal to value of the function. What is the limit of the function? Limit x tends to 0 x into sin 1 by x. For all x belongs to R, mod of sin 1 by x less than equal to 1, which implies this: mod of sin 1 by x greater than equal to 0 less than equal to 1. 0 into x mod less than equal to x mod into mod of sin 1 by x less than equal to 1 into x mod, which implies this: 0 less than equal to x in 1 by x, its modulus less than equal to x mod. Since a mod into b mod is equal to a b mod. Taking limit throughout, 0 less than equal to limit x tends to 0 mod of x into sin 1 by x less than equal to limit x tends to 0 x mod. Limit of 0 is 0. Limit of x mod at x equal to 0 is 0, which implies this: 0 less than equal to limit x tends to 0 mod of x into sin 1 by x less than equal to 0. By sandwich theorem, we have limit mod of x into sin 1 by x is equal to 0, which implies this: mod of limit x tends to 0 x into sin 1 by x is equal to 0. Since limit x tends to a mod of fx is equal to mod of limit x tends to a fx. Clear? Clear? According to this rule, we can write this equal to this, which implies this: limit x tends to 0 x into sin 1 by x is equal to 0. Since modulus of 0 is equal to 0, now we have limit x tends to 0 x into sin 1 by x is equal to f0 is equal to 0. Therefore, f is continuous at x equal to 0. Clear? Clear? Okay, next question. Determine the value of k for which the following function is continuous at x equal to 3. The function is continuous at x equal to 3. Limit of the function is equal to value of the function at x equal to 3. Answer: f is continuous at x equal to 3, which implies this limit extends to 3 fx is equal to f3, which implies this limit extends to 3 fx x plus 3 whole square minus 6 square divided by x minus 3. F3 is given by k, which implies this limit extends to 3 x plus 3 whole square minus 6 square. X minus 3 can be written as x plus 3 minus 6, which is equal to k. Clear? X plus 3 minus 6, that is x minus 3, which implies this 2 into 6 to the power 2 minus 1 is equal to k. Since limit extends to a s to the n minus a to the n divided by x minus a is equal to n into a to the n minus 1. S to the n minus a to the n divided by x minus a form, which is equal to k 2 into 6, that is equal to 12. Clear? Therefore, k is equal to 12. So that the function is continuous at x equal to 3. Clear? Next question. Examine the continuity of the function fx defined by fx is equal to e to the power 1 by x minus 1 whole divided by e to the 1 by x plus 1 if x not equal to 0 and its value is 0 at x equal to 0. We have to test the function is continuous or not at x equal to 0. Answer: given f0 is equal to 0. That means value of the function at x equal to 0 is 0. LHL, left hand limit at x equal to 0. Limit extends to 0 minus fx, which is same as limit extends to 0 minus fx means e to the power 1 by x minus 1 divided by e to the 1 by x plus 1. Put x is equal to 0 minus h. H tends to 0, h is greater than 0. That means h is arbitrarily very small positive number. H tends to 0 plus. Clear? Limit h tends to 0 plus e to the power 1 divided by 0 plus h. Sorry, 0 minus h. divided by e to the power 1 divided by 0 minus h plus 1, and it is minus 1, which equal to limit h tends to 0 plus e to the power minus 1 by h minus 1 divided by e to the power minus 1 by h plus 1. Since h tends to 0 plus 1 by h tends to positive infinity, which implies e to the minus 1 by h tends to negative infinity, which implies e to the power minus 1 by h tends to 0. So, limit h tends to 0 plus e to the power minus 1 by h is 0. 0 minus 1 divided by 0 plus 1, which is equal to limit h tends to 0 of minus 1. Limit of constant is equal to constant, that is equal to minus 1. So, the left hand limit is equal to minus 1. Clear? RHL. Right hand limit at x equal to 0. Limit x tends to 0 plus fx is equal to limit x tends to 0 plus, that is fx, e to the power 1 by x minus 1 divided by e to the 1 by x plus 1. Put x is equal to 0 plus h. X tends to 0 plus. Put x equal to 0 plus h. H tends to 0. H greater than 0. That is h tends to 0 plus. So, limit x tends to 0 plus implies h tends to 0 plus e to the power 1 divided by 0 plus h minus 1 divided by e to the 1 divided by 0 plus h minus 1, which is equal to limit h tends to 0 e to the power 1 by h minus 1 divided by e to the 1 by h minus 1, 0 plus, dividing e to the power 1 by h, 0. It gives 1 and it gives e to the power minus 1 by h divided by 1 minus e to the power minus 1 by h. Dividing e to the 1 by h is numerator and denominator. E to the minus 1 by h is 0. Limit h tends to 0, 1 minus 0 divided by 1 plus 0, which is equal to limit h tends to 0 plus of 1, which is equal to 1, is the right hand limit of the function at x equal to 0. Clear? LHL is not equal to RHL. The right hand limit is minus 1. Sorry, the left hand limit is minus 1 and the right hand limit is plus 1. LHL not equal to RHL. Therefore, F is discontinuous at x equal to 0. Clear? Clear? Next question. Test the continuity of fx at x equal to 0 be defined by fx is equal to 1 divided by x plus x bracket if x less than 0 and minus 1 if x greater than or equal to 0. Answer given value of the function at x equal to 0, that is f0 is equal to minus 1. LHL at x equal to 0, that is limit x tends to 0 minus fx. Limit x tends to 0 minus means x less than 0. The function is defined by 1 divided by x plus bracket of x. Put x is equal to 0 minus h tends to 0, h greater than 0, that means h tends to 0 plus. H tends to 0 minus, which is same as h tends to 0 plus 1 divided by x is equal to 0 minus h. Bracket of 0 minus h. Limit h tends to 0 plus 1 divided by minus h, bracket of 0 minus h, that means bracket of minus h is equal to minus 1. Limit h tends to 0 plus of minus 1. H tends to 0, this value is 0, which is equal to minus 1. The left hand limit at x equal to 0 is minus 1. RHL at x equal to 0. Limit x tends to 0 plus fx is equal to limit x tends to 0 plus, that means x greater than 0. X greater than 0, the function is defined by minus 1. Limit of constant is equal to constant, that is equal to minus 1. The left limit is equal to minus 1. The right limit is equal to minus 1. Value of the function is minus 1. Now we have limit x tends to 0 minus fx. That means left hand limit of the function at x equal to 0 is equal to limit x tends to 0 plus fx. Right hand limit of the function at x equal to 0 is equal to f0. All are equal to minus 1. Therefore, f is continuous at x equal to 0. Left hand limit is equal to right hand limit is equal to value of the function, each equal to minus 1. Therefore, the function is continuous at x equal to 0. Clear? Next question. If fx is equal to s square plus b if x less than 1, fx is equal to 1 if x is equal to 1, fx is equal to 2x minus b if x greater than 1. Is continuous at x equal to 1, then find a and b. Given the function is continuous at x equal to 1, given fx is continuous at x equal to 1 implies left hand limit at x equal to 1 is equal to right hand limit at x equal to 1 is equal to value of the function at x equal to 1. Here the function is continuous at x equal to 1 means left hand limit at x equal to 1, right hand limit of the function at x equal to 1 is equal to value of the function at x equal to x tends to 1 minus, that means x less than 1. X less than 1, the function is defined by as square plus of b. Limit x tends to 1 plus means x greater than 1. The function is defined by 2x minus of b. Value of the function f1 is given by 1. It is not in the indeterminate form. It is also not in the indeterminate form. So the limiting value is equal to value of the function. Putting x equal to 1 at x, it gives a plus b, which is same as 2a minus of b is equal to 1. A plus of b is equal to 1. 2a minus of b is equal to 1. 3a is equal to 2. A is equal to 2 by 3. b is equal to 1 minus a, which is equal to 1 by 3. Therefore, a is equal to 2 by 3 and b is equal to 1 by 3 is the answer. Clear? Okay, next question. If fx is equal to sin ax divided by sin x, if x not equal to 0, 1 by a, if x equal to 0, is continuous at x equal to a, then find a. Answer: fx is continuous at x equal to 0, which implies limit of the function at x equal to 0 is equal to value of the function at x equal to 0. Clear? Limit x tends to 0, what is fx? Sin x divided by sin x. f0 is equal to 1 by, which implies limit x tends to 0 sin ax divided by x whole divided by sin x by x. X is cancel into a cancel, which is equal to 1 by a. Clear? X tends to 0, sin theta by theta is equal to 1. Implies 1 into a, and the denominator sin theta by theta is equal to 1 is equal to 1 by a. A square is equal to 1 implies a is equal to plus minus 1. Answer. Clear? Okay. Next question. If a function is continuous at x equal to a, then limit epsilon tends to 0, half of f a plus epsilon plus f a minus epsilon is equal to dash. It is not in the indeterminate form. So the limiting value is equal to value of the function for epsilon equal to 0. So answer is half of f of a plus 0 plus f of a minus 0 is equal to half of fa plus fa is equal to 2 times of fa divided to is equal to fa. Clear?